All right, now we went over the first thing. It's time to go over the second thing. The second thing you need to know for Math 1 is how to solve an equation. Okay, well, first of all, we need to go over a couple of terms. What is a variable? Well, we're solving for a particular variable. A variable is an unknown quantity. Okay, usually we think of the variable being x. It doesn't always have to be x. It doesn't always have to be a letter. You could say triangle or marker. You can substitute anything. Anything could be a variable. The variable is standing in for an unknown amount or quantity that we are looking for. Okay? Well, we're solving equations. What is an equation? Equation has the root word equals in it. So what we have is we have a quantity equal to another quantity. Okay? How do we solve equations? To sum it all up, you've been doing this for quite some time, but to sum it up on the board here, solving equations, another way of saying that is that you're isolating the variable. That's how you do it. To isolate something means to put something by itself. So if we're solving for x, we want to get x by itself on one side of the equation, one side of the equal sign. And we do this by working backwards. Okay? We just talked about the, please excuse my dear Aunt Sally. In essence, we work this way, for please excuse my dear Aunt Sally. If we're solving equations, we want to work in the opposite direction, meaning we want to take care of our addition and subtraction first, then take care of our multiplication and division, and then take care of our exponents. Okay? We want to work backwards. Well, let's start with an easy example here. I have an example of negative 5x plus 10 equals negative 15. Okay? Something that you're going to hear me say a good bit if we're solving equations is what is the number that is closest to the x? In this case, the negative 5 is the closest to the x. If the negative 5 is the closest to the x, we want to undo it last. Okay? Whatever's the closest, you undo last. Whatever's the furthest away, in this case would be the plus 10, we want to undo first. And it does follow the working backwards from the PEMDAS. We want to undo this addition first. Okay, so I'm going to grab my red pen here. The opposite of adding 10 would be to subtract 10. Now, to keep it balanced, whatever you do to one side of the equation, you have to do to the other side of the equation. So I'm going to subtract 10 from the other side. Okay? Now, we know that a positive 10, take away a 10, gets rid of it. That's the whole point. We're trying to get the x by itself. Then we have negative 15 minus 10, which is going to give us a negative 25. Bring down the equal sign, bring down the negative 5x. Now we have a new equation, an equal equation. The x hasn't changed. We're trying to keep it balanced on both sides. Now we have negative 5x equals negative 25. What you need to do is you need to ask yourself, how is the negative 5 attached to the x? In this case, it's attached by multiplication. Then you ask yourself, how do you undo multiplication? You divide. So we're going to divide by negative 5. Whatever you do to one side, you must do to the other side. Negative 5x divided by negative 5, the negative 5's cancel out. Actually, it becomes a 1. And 1x is just the same thing as saying x. Okay? So this side is just going to be x. Bring down the equal sign. And we have negative 25 divided by negative 5. You got to think about your division rules here. A negative divided by a negative is going to be a positive. And 25 divided by 5 is going to be a positive 5. We have solved the equation. We have isolated the variable. The variable in this case is x. We have isolated the variable. It is by itself, and we have come up with a quantity of 5. Now, the beauty of the whole deal of solving equations is that you can do this, and you should know for a fact if you're right or wrong because you're able to check your answer. How do you check your answer? You take the answer that you got and you substitute it into the original problem. So the original problem stated that minus 5x plus 10 equals negative 15. Okay? Well, instead of x, remember, we just found x. I'm going to take that out and I'm going to put in what we found. We found that x was 5. Now we do, please excuse my dear Aunt Sally, the order of operations, which states that we have no parentheses here. We have no exponents. We do have multiplication. Negative 5 times 5 is negative 25. Plus 10 equals negative 15. And we do have an addition here. Negative 25 plus 10 is going to leave us with a negative 15 equals negative 15. What you should end up with is a true statement. If this is true, if that statement that you end up with is true, then what you have found to be the solution for x has got to be correct. That's one example. Okay, we got a new problem here. And this time I state that we have the example 3x squared plus 8 equals 20. Okay? We're going to solve the equation. We're going to isolate the x. The questions I told you to ask yourself before is, what is the closest number to the x? Ask yourself that question now. Okay? Is it the 3, is it the 2, or is it the 8? You got three options. The answer is the 2, the squared. The squared is what's closest to the x. So that's what you undo last. This is what you undo last. Okay, what's the next closest, I guess you should say. And in your head you should see that the 3 is the next closest. So the furthest one away is the plus 8. Whatever's the furthest away is the first thing you undo. Remember, we're working backwards from the order of operations. So we're going to undo, most of the time, we're going to undo our addition and subtraction first. So to undo a plus 8, we're going to do the opposite. We're going to subtract 8 on both sides. Both sides of what? Both sides of the equal sign. Okay? Some people make the mistake of subtracting the 8 on the same side. Remember, you're trying to keep it balanced. If something is equal, the two sides have to stay balanced. Just think of a weight balance. Okay? If you take away take away 8 from this side, it's going to get lighter. So to make it balanced again, you got to take away 8 from this side. Bring down what you have not affected. So this side I'm going to bring down to 3x squared. Okay? These cancel out. And then 20 minus 8 is going to give me 12. Beautiful. Okay, now, again, we all know the last thing we're going to undo is the squared. So the next thing we've got to get rid of is the 3. Ask yourself, how is it attached to the x? It's attached by multiplication. To undo multiplication, you have to divide. Whatever you do to one side, you must do to the other side. Remember, the equal sign is what divides the two boundaries up. Whatever you do to one side, you must do to the other side to keep it equal. These cancel, you're left with an x squared equals 4. Okay? Now, we finally got to the point where we got to get rid of the square. To get rid of a square, you take the square root. Okay? Whatever you do to one side, you must do to the other side. Okay? The square root of a square is like saying the opposite. It's like multiplying to undo division. It's like adding to undo subtraction. You take the square root to get rid of a square. So really and truly, these are going to kind of cancel each other out. What you're going to be left with is you're going to be left with an x. Now, square root of 4. 4 is what we call a perfect square, meaning that if you take the square root of it, you get an equal, nice, even number. In this case, it's 2. Hopefully you know that it's not just positive 2, it's also negative 2. So we're going to put a plus or minus 2 in front of that. Why is that the case? Because a 2 times 2 is 4, but also a negative 2 times a negative 2 is also 4. Remember, positive times a positive is a positive, and a negative times a negative is also a positive. So we have our answer. We've isolated the x. The x is by itself. We have two answers. That's okay. But we can check both answers in our original equation. So here's our check over on this side. And we're going to do two checks. The first check, we're going to use the original problem, and I'm going to substitute in 2. So 3 times 2 squared plus 8 equals 20. Please excuse my dear Aunt Sally. Let's do the parentheses and the exponents, which will be 4. So 3 times 4 plus 8 equals 20. 3 times 4 is 12. Plus 8 equals 20. 12 plus 8 is going to give you 20 equals 20. True statement. True statement, 2 works. Okay? Same thing as if I do it over here and I check negative 2. 3 times negative 2 squared plus 8 equals 20. Be careful with how you write the parentheses here. This is negative 2 squared. I'll give you another example. This is not negative 2 squared. What I've written right here is actually take the opposite of 2 squared. If you're doing order of operations, remember you do the exponents first and then you do the multiplication. that's really a -1 in front of that 2. So in essence, this is not going to be 4. This is actually going to come out to be -4, and that's not what we want in this case. Okay? -2 squared is -2 times -2, which is going to give you 4. And 3 times 4 plus 8 is what you come up with. 3 times 4 is 12 plus 8. 12 plus 8 is 20. And 20 equals 20, which is a true statement. So we know that it both works, and we are happy. Marker, 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 marker.